Hey guys, welcome back. So we're going to continue our discussion of thermochemistry now, and we're going to get into the energy portion of this. So I'm going to go ahead and share my screen so we can talk about this. So let's do this. Okay, so what is it that we're going to be talking about at this point? Well, let's see. The nature of energy and the types of energy that exist, the energy changes in chemical reactions. We'll talk about an introduction to thermodynamics, which is the next topic that we're going to cover. And then we'll talk about the enthalpy of chemical reactions, and I'll define what enthalpy is and talk to you about what that means. Okay, so that's where we're headed for today, and let's see how we can get there. So, questions, comments, problems? I hope that there are none, but if there are, please let me know. Okay. Come on, work with me. There we go. So, just a note about this lecture. Unlike most of what we do, this lecture is almost all theory. There's not a lot of practical application for what we're doing. We'll do some, and that's based on the enthalpy that we'll be talking about. We'll do that again next time, but it's very dry. It's mostly definitions. It's not a lot of really interesting stuff. The lectures for the last few parts are going to be pretty boring and not very long. So there are a lot of practice problems for the material on its own. This material will not play a part in what we do, will play a big part in what we do after this. So it's really important to understand these concepts, but it's not easy for us to ask questions about them until we get all the concepts down. So you'll find that as we get to into entropy, which is not the next lecture, but the one after that, we'll start combining concepts from this lecture into that. And then once we go into free energy, we'll take all this stuff from enthalpy and entropy into that discussion. So it's really important to understand the concepts, but you may not feel like there's a lot of practical application to it for a little bit. And that is sad, in my opinion, but that's the way this works. So there are going to be a lot of define this, tell me the sign conventions, that kind of stuff. So just be prepared. So let's talk about the nature and types of energy. So energy is the capacity to do work. There are several types that we talk about. So there's radiant energy. Solar energy comes from the sun, heats the Earth's atmosphere, the surface, stimulates vegetative growth, and climate patterns. Okay? There's thermal energy, which is energy associated with random motion of atoms and molecules. So as things move around, that generates heat that comes with that. So that's thermal energy. It's directly related to the temperature. Energy is a function of both the amount of material and its motion. So larger masses have a higher amount of energy. More material, more energy. Chemical energy is stored within chemical substances. Chemical reactions release it during bond breakage, store it during bond formation, and convert energy to other forms. So when we go from one type of bond to another, we typically either gain or release energy in doing that. We move things around. We do not create or destroy them when we're talking about chemical reactions. Now, from 110, we talked about nuclear reactions. That's a different concept. Those are different things that we're talking about there. So that's not what we're going to be talking about here. And then there's potential energy. That's energy available based on the position of a material. So if I've got something that's held up really high and I drop it, we end up with a lot of motion energy from that motion. Okay, so its height gives it that energy. That's potential energy. This is really a physics thing, and I'm not great with physics, so there you go. The law of conservation of energy states that the total quantity of energy in the universe is assumed to be constant. Energy is neither created nor destroyed, only converted from one form to another, and that includes nuclear energy, okay? So we can't make it. We can just convert it, okay? What we talk about in chemistry is converting through those chemical bonds. All right, so it's important that we understand the law of conservation of energy. So there's that. And these are the 4 types of energy that we'll be talking, or at least that you've gotten mentioned. So questions about that? Hopefully not. You may get asked for, name a couple of types of energy, that kind of thing. You may get asked about the law of conservation of energy. We'll look at some sample questions a little bit later. Energy changes in chemical reactions. So most chemical reactions involve the exchange of heat. So thermochemistry is the study of heat change in chemical reactions. That's what we're going to be talking about. It is the transfer of thermal energy from a material higher in energy to one lower in energy, usually measured by the temperature of that material. In order for us to be able to talk about that, we need to be able to talk about a bunch of different concepts. So the first is the system. We define the system as whatever part of the universe that we're trying to look at. It can be defined in any way you want. Usually we're talking about, hey, what's in this beaker? That's the kind of way that we talk about it in this. We could be talking about what's inside a calorimeter. We could be talking about what's inside a room. We could be talking about what's inside a stadium. We could be talking about what's in the lower Earth's atmosphere versus higher Earth's atmosphere, what's in the core of the Earth. Our system can be anything. We just have to define what it is. Okay. Anything that is not our system is the surroundings. Okay. So everything else outside of our system is our surroundings. And there are three types of systems that we need to be able to deal with. One is an open system, and that means it can exchange mass and energy with the surroundings. So I can transfer both mass and energy. A closed system allows the transfer of heat, but not mass. Okay, so all of the mass is trapped, but I can transfer heat between them. Okay. We also have something called an isolated system, where there is no transfer of heat or mass. Okay, so that's an isolated container. We have everything very well controlled. So that's an isolated system. So those are the three types of systems we need to be able to consider. Remember that, especially when we talk about thermal properties, having a closed or open system can be problematic because we could lose it anywhere and we have no idea necessarily where it's gone or how to measure them. So that's why we typically look at thermal things in an isolated system so that we don't lose that energy. Okay. Now we need to talk about heat transfer. And you've heard these words before. I've used them in the past. Exothermic and endothermic. So energy is given off from the system to the surroundings. Heat is a product in an exothermic reaction. In an endothermic reaction, energy is taken in by the system from the surroundings. Heat is a reactant. And I'll show you that. I mean, we talked about it in terms of energy diagrams before. So we looked at in the reaction rates. In reaction rates, we looked at this. And so this is our reaction progress on this axis. And then this is energy going up, because I don't like unlabeled things. If we start here, A plus B is our reactants. We have our activation energy, and then we come down here, or A plus B is our reactants. We have our activation energy, and then we come out here. Notice that this gap, we go up. So since there's an up, that excess energy is lost. This is endo. We require that energy to be put in, so that's an endothermic. This, on the other hand, that energy is lower, and that gets lost outside, so that's an exothermic. So when we look at our reactions, when we see an exothermic reaction, we may see plus heat as a product. And over here, we would have plus heat as a reactant. So that's what we're talking about for that, okay? So those are some of our terms. Some possum questions about our terms. Hopefully not. If there are, you can always reverse and go back and hear what I said. It's a fun part of taking classes online. Now, the next thing we're going to talk about is thermodynamics. I'm going to pause here after all of our definitions, and I'll come back in just a minute and get back to what we're talking about. Thanks, guys.